Hello everyone, today we will model a thin wall inside a fluid domain. The thin wall concept can be used to model butterfly valves, turning vanes, or any structure that can be represented as a thin surface. In this case, we will model a butterfly valve installed at 45 degrees in a circular pipe with a diameter of 1 meter. Let's create the pipe first. We define our points showcased in the table on screen. Next, we need to create a cylinder using the cylinder tool and selecting the middle point and top point on the left as well as the rightmost point. With the cylinder created, use the circle creation tool to create a circle on the left face using the middle and radius points. Now we can select the left face and create a surface. Once the surface is created, select it and use the geometry operation rotate to rotate it 45 degrees in the gamma direction. We will then move it 4 meters along the x direction so it is positioned correctly inside the cylinder. Now we can move on to naming. The front face will be called inlet, the back side will be called the outlet, and the cylinder side surface will be the wall by default. We will hide the body to access the internal disk and call it valve. Now that we have all the bodies and surfaces named, we move on to the mesh tab. For the mesh, we will use the default cell size. We need to use the surface refinement button and enable the thin wall type. We select the valve surface and set the refinement to 0.02. You can preview the sizes to ensure the mesh is appropriately refined around the disk. Once satisfied, you can add it and apply it, and close, and generate the mesh. The resulting mesh should be around 130,000 cells, which is good for orthogonality and skewness. You can see the refined cells surrounding the thin wall disk if using a z-axis section view. In the setup, we will change the turbulence model to k-epsilon and set the fluid material to water. For the boundary conditions, set the inlet velocity to 5 meters per second with a length scale of 1 meter. For the outlet, we will use standard pressure equal to the ambient environment. The pipe side is a standard wall, but for the thin wall valve, set it as a regular wall in the interface. Now we can go to Solution tab. In the Solution tab, we will set up a monitoring point 5 meters behind the disk to track velocity magnitude. Once the monitors are set, run the simulation. Once the Simulation tab is done, we can move on to the Results tab. In the Results tab, here we can create a default plane in the XY orientation to visualize the velocity profile. You can clearly see the flow behavior around the 45-degree disk. We can also switch the view to pressure to see the pressure changes across the pipe. Finally, you can generate a full report of the simulation parameters and findings. Thank you for watching and happy simulating.